So this one is asking us to look at the scatter plot and determine what the trend line is for this data. It looks like it's a negative trend line. Because as numbers on the x-axis get larger, the data points seem to be decreasing. Now, that's not true of all of them because they're more scattered than they were before. There's a lot more variation in where the dots are being plotted than the previous example that I showed you. But in this case, it still does look like the data is decreasing. So what we're going to do is we're going to attempt to use a line to graph the trend and then pick some points to calculate the rate of change. So I'm going to just go through a few points, but I'm also going to count how many I have above and below. So I have 3, 4, 5, 6, 7, 8 below, and 1, 2, 3, 4, 5 above, and then 2 are on it, sitting on the line. So it looks like I need to bring this down a little more. I'm going to pull this down so that I'm only hitting one dot. Now, does that mean I have to hit one of the dots or the scatter plot dots? No, that doesn't actually mean that I need to do that. But also remember that the further the outlier is, the more likely that one, it will pull the line closer to it. It will affect where the line is graphed. But just remember that you could actually plot a trend line without ever touching any of the dots. So let's count how many are now above and below. So we have 1, 2, 3, 4, 5, 6, 7 below, and 1, 2, 3, 4, 5, 6, 7 above. And I'm touching one of the dots, which is fine. So I think this is a better graph of the line than what we had the first time I plotted it. So feel free to just, try something, and if it doesn't work out, try it again. Count the dots, make sure it's kind of about where it needs to be. What's the average rate of change? Well, we need to figure out two nice places to calculate data. So I'm going to go ahead and use the 1 point we crossed over. And I'm also going to use a very convenient dot over here at 9, 0, because that's another point that our trend line crosses. So we have the point 4, looks like 4, 5, and also the point 9, 0 as our 2 points to calculate the slope or average rate of change. Now remember, this is an approximation. This isn't actually representative of every single point on here. So our slope is going to be 0 minus 5 over 9 minus 4. Notice that I'm using this as my second point and this is my first point. So if you are taking notes, 9, 0 is my second point, 4, 5 is my first point. And this gives me negative 5 over 5, which gives me negative 1 as my rate of change or my slope. So now what would the function be? Well, I can look at this graph and I can approximate where I think the y-intercept would be. It looks like it's going to be at 9, and I could also use one of these points as a quick check. If I say y equals negative 1x plus b, and my slope is negative 1, and my x is 9, so I can find b. So I have 0 is equal to negative 9 plus b, so b equals 9. Now I could have just recognized that was true based on the fact that the slope is negative 1, but you can also do a quick calculation to make sure your mental math is working for you. So the function for this would be f of x is equal to negative 1x plus 9. Welcome back, everyone. We are now going to look at some data plots or scatter plots that do not necessarily follow a linear pattern. Notice that the data in this scatter plot looks like it is curving instead of straight. Now, if we were asked to create a regression line for this data, a linear regression line, we would draw a straight line through this and say, well, that looks like the linear regression. And you wouldn't be wrong, but it might not be the best fit. To me, this looks more logarithmic in form. So if it was logarithmic, it would look something like this. Go back to your first page of this outline just to refresh your memory. Now, yes, the data points don't perfectly fit this curve, but they are better fit than a linear function. You could also argue that this would make a good quadratic data regression, but you'd only be using a small part of your parabola. So your parabola, let me just clear this really quick. If you were sketching a parabola, it would probably look more like that. And that would be a downward facing parabola. So your function would look like f of x equals negative a x squared plus bx plus c. Now we are not going to be able to calculate a trend line other than to say the data is increasing. And it looks like it's increasing either logarithmically or quadratically. And I don't even think that's a real word, but quadratic. I'm going to say Lee anyway, quadratically. Oh, don't quote me on that. But you understand the point I'm making by coining that word. Basically, is it forming a pattern where it looks like a logarithm, where it increases fast at first and then flattens out, and the data would trend out kind of like this, the purple line? Or is it more quadratic in form, where you reach a maximum somewhere here and then you decrease again? This would be based on what kind of data this is modeling, and we haven't told you which one it is. So I would accept either one of these solutions or descriptions for this data. What is the average rate of change? Now, this is not a helpful question, because if you look at the data, you would have to be given an interval to calculate the average rate. And so let's just say curve with no specific interval given. So that's enough for now. If I were to give you an interval, then you would be able to find those 2 points. So let's just say I had been thinking about it and I wanted to find the average rate of change between 2 of the points that hit the curve. Well, I would just use those 2 points and find the rate of change between those 2 points. But we weren't given 2 points to calculate, and so we're going to move on. What type of function would this be? Well, it would be this function right here. F of x equals, we're going to go with quadratic for now. So if it was quadratic, the function would be f of x equals negative ax squared plus bx plus c. And if it was logarithmic, it would be of the form f of x equals a plus b ln of x.